Hello guys, I welcome you all for the third module on networking from the course on Introduction to Internet of Things for Core Engineering. So in this today's session we are going to see about the internet structure, protocol and what is protocol stack. So let us begin the session. So internet structure. So ad hoc internet connection, ad hoc is the interconnection of network. The ad hoc structure is unpredictable and can be changed by anyone at any time. The message travels from the source to destination by hopping through the network. Um, so the ad hoc network is what we already discussed. Um, so this is the network. This is the source node, and it will be connected to the certain different node element. So this is another network. So this is another network. So if we want to transfer a message to H, it need to first communicate with the it need to first communicate with the A. So this is called as a sync node. From the sync node, it will be communicated with the G node, and from the G node, it will communicate with the H node. So, so each and every node can be relocated from this location to this location, and it can join with this router. So this is what called as the hopping from one network to another network. A node can be hopped from one network to another network. So this is what this is being for example, if a new device is that is being connected with a particular network, so that network will automatically configure a particular address, and the router it will automatically configure which is the shortest path for the particular new node that is being attached. So this is what called as the internet structure. So the internet protocol, so the protocol with the certain rules and regulations that has to be maintained how the data has to be transmitted over a network. So that is called as a internet protocol. How it is possible to send the bits across incompatible compatible network. For example, I'm located at Coimbatore and I want to transfer a message to a particular person in Seattle. There are larger number of network. For example, I have to my data has to travel through the local network which I'm being connected, and has to be connected with the local Indian server, and it has to be connected with the worldwide server. From the world server, it has to go for the USA server, USA to the Seattle server. So in Seattle, it has to be where he is being connected. It has to be he may connect with the particular network. He may changes this location from particular location to the another location, but the IP address, that is the email address what he is having, that has that email has to obtain the data what I'm being sent. So that is what in what format I'm going to send the data, whether it how it's being packed, how what protocol we are going to use it. So everything is matters here in the internet protocol. So the solution for the internet protocols are the protocol software running on each host and router. This protocol software is very important, and common communication rules for all the network. So all the networks should have the common communication rules. So if each and every network have following a different rules, that there will be a very critical problem will be there. We cannot reach our destination properly. For example, I'm having an IP version 6 and he is having a different version that is being developed by himself. I cannot reach my destination in the proper time. So implement protocols as a set of rules governs how host and router should cooperate when they transfer the data from the network to network. The TCP and IP is a protocol for the global IP internet. So the most commonly used protocol that is being available in the internet is TCP bar IP, that is a transport control protocol and internet protocol. So these are the main protocols which is being used for transferring the data through internet. So what does the internet protocol do? So internet protocol will provide the naming scheme. Internet protocol defines a uniform format of the host address. For example, so all the host address will be having the XXX, 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 and this kind of in case if it is a IP version 4. In case if it is a IP version 6, so it will be in the format of, so this is a 4-bit and this is a 4-bit, a 4-bit and 4-bit and 4-bit and 4-bit. So there are multiple, these are the two different host addresses that is being followed currently. So the IP version 4 and IP version 6. So each host and the router is assigned at least one of these unique internet addresses has to have. So otherwise we cannot reach our destination, or the data cannot be transported from the source to the destination. So next one is a protocol model. So that this defines the rules to determine how the computer will communicate. The CB radio protocol, that is over and it's a kind of a CB kind of a radio protocol. It's I mean the over I'm done talking. Roger, data receiving. So there will be a certain request will be there, and response will be there, and it is communicated in the continuous manner. It will follow certain border to communicate from the host to the destination. The rule enables efficient communication. These rules are indicates how the data has to be efficiently transmitted over a particular network to reach its destination. So network protocol. So many networking tasks to transmit and receive data, the routing, flow control, and attribution are the main important factors. So the OSI divides these tasks between the networking abstraction layers. There are the 7 OSI layers has been developed so that the data will be traveling from the source to the destination. It has to follow the certain levels of data, and it has to be converted in a proper digital format. Then it has to be transmitted over the Ethernet lines. So each layer uses a different data, and the routing requires a network topology, and arbitration may use a message prioritizer. So the OSI layer concept. The OSI layer concept is a very old concept. Still we are using it. So the message is received at each layers, and decisions are made how the message has to be converted. For example, in application layer, the message has to be in a viewable format, and there are different layers are available. So the message M is received at a layer R. The layer R identifies the route from the message M, and the layer R adds the routing information by creating the M dash, and the layer R passes the M dash to the next lower layer. So the processing will be happen in the layer, and it will be M is converted into the M dash, and again it will be processed to the another lower level of layer. So encapsulation, the data is not going to transmit as a same data of a digital for binary format. It will be encapsulated in a particular format. It will be enclosed, and it will be packed in a particular format, and then it will be transmitted. The communication tasks are confined to the one protocol layer. The protocol stack is the implementation, usually software of each protocol layer. So encapsulation in terms of transmission, the message starts at the top layer, and that is from the application layer, it goes to the physical layer. So that is at the bottom layer. So the message decisions are made at each layers. We will be looking over what are the different layers in the OSI in upcoming slides. So the relevant information is added to the message at each layer, the header or footers. So the reception, the message start at the bottom and later go up in the reception, that is from the physical layer to the application area. application layer. The relevant information is stripped at each layers and the new decisions are made if necessary. So this is what will be continuing in the next lecture about the what are the different types of the OSI layers, and we'll be discussing what is the actual process that is happening in the each layer in the upcoming slide. Thank you all.